Hello, today we are doing our second lesson on mean, median, mode, and range, which is going to focus on outliers. We're going to start off with a review of finding mean, median, mode, and range. So we're going to look at some temperatures. It says find the following for the list of temperatures. Mean, first our mean is adding up all of our numbers and dividing by how many numbers we have. And we have 1, 2, 3, 4, 5, 6, 7 temperatures. We're going to divide by 7. So if we add all of these up, 20 plus negative 11. Remember, when you plug in a negative in your calculator, to use the button that looks like that. Plus 72 plus a negative 1 plus 9 plus 17 plus negative 5 gives us 101. So if we divide that by 7, we get 14.4. 4 degrees, because we're talking about temperatures. Our average temperature is 14.4. Our median then is the number that's in the middle. So we need to put these in order from least to greatest, least being our biggest negative number. So negative 11, then negative 5, negative 1, then we have 9, 17, 20, and 72. So warm 1. So if we find our number in the middle, cross off 1 on the left, 1 on the right, 2 on the left, 2 on the right, 3 on the left, 3 on the right. Our median in the middle is 9. Right there. Then our mode is the number that's used the most. There is none. No number is used more than once. Sometimes I might say all of the numbers because they're all used once, but I don't like to do that. And then range, biggest number minus the smallest number. So we have 72 minus a negative 11. So two negatives really here make a positive. So 72 plus 11 should give us 83. What this is telling us is it's the range between the smallest number and the largest number. So on your thermometer, if this is 0 and we have 72 way up here, the difference between negative 11 and 72, well, we are really adding them together because the difference between here would be going up 11 and then going up 72 more. So yes, we did go up 83 degrees between negative 11 and 72. Now we're going to get into our new piece of information. It says outliers. Values in data in a data set that are much greater or much less than the others. So it says here also, a small outlier will make the mean or the average smaller. A big outlier will make the average bigger. So it says, which temperature is the outlier? If all of the numbers are pretty close together and one is just way off, that's considered an outlier. If it's hard to tell, you can plot them on a number line. So if we look at our temperatures that we just had from the previous slide, here's 20 degrees. Negative 11 would be around here. 72 would be way up here. Negative 1 is right here. 9 is right here. 17 around there. And negative 5. So you can tell that most of our data is pretty close together right here. And then there's this one number way over here, like really warm day. So 72 is our outlier. It's way bigger than all the rest of the numbers. So we did find the mean of this data on the previous slide, 14.4. Now they want to know what would the mean be without the outlier. So now we're going to add these all up and divide by 1, 2, 3, 4, 5, 6, 7. So there were 7, but if we eliminate this one, now there's only 6. So let's add those numbers up. 20 plus negative 11, or really minus 11, plus negative 1, plus 9, plus 17, plus negative 5, gives us 29. 29 divided by 6 gives me about 4.8. So how did the mean change without the outlier? Well, it was 14.4, and now it's 4.8. So it went down about 10 degrees. Oops, that's percent. Went down about 10 degrees without the outlier. Which this average is more representative of this data because we don't have any points between here and here. That one's really far up there. So let's take a look at a couple more. It says find the mean, then is there an outlier, find the mean without the outlier, and then how are the means different. So first we're going to find our mean, add them all up, and divide by 1, 2, 3, 4, 5, 6. So 72 plus 107 plus 2 plus 85 plus 96 plus 54 gives us 416 divided by 6 numbers is 69.3. So right now our average is at about 69, 70 about. It says, is there an outlier? Is there a number that's way bigger or way smaller than all the rest? Well, this number 2, there are no other numbers that are that low. All the rest of the numbers are around 50 to 100. So within that range. So I would say yes, there is an outlier. Our outlier is a number 2. It's way smaller than all the rest. So now if we eliminate that one, find the mean without the outlier, now we only have 5 numbers. And we know 416 was all of the numbers added up, so we can just subtract the 2. 416 minus 2 is 414. So 414 divided by 5 numbers gives us 82.8. Now this 82 is more representative of the numbers that we have. It's about in the middle of all of those, where 69 was a little bit on the low end. So how are the means different? Our mean increased. If you want to say by about, I don't know, what did it go up by? From about 70 to 82, so about 12 to 13? Somewhere around there. If you want to actually calculate it out, great. But our mean increased or went up. So because we had a really small outlier, it made our mean smaller. Then when we got rid of that outlier, it made our mean larger because all of the numbers were then bigger. All right, let's take a look at the next one. Find the mean. We have 1, 2, 3, 4, 5, 6 numbers again. So we're going to add them up. -5 plus 0 plus 10 plus -11 plus 85 plus 17. Total we have 96. 96 divided by 6 gives us 16. So our average or mean is 16. Is there an outlier? All of our numbers are near 0, negative or positive. This 85 is huge compared to the rest. So yes, there is an outlier. It is 85. Now I need to find the mean without it. Without it, we only have 5 numbers. Oopsies. So we know altogether with all of the numbers it was 96. So if we subtract 85, adding up all of these numbers and this one gives us only 11, which makes sense because some are negative and some are positive. So 11 divided by 5 gives us 2.2, which makes sense because our average is pretty close to 0, some negatives and some positives. There's just a few more positives. So how are our means different? Our means, the new mean is decreased by about 14 because of our large outlier that we took out. Our mean was bigger because we had a big outlier, but when we took that out, now this is more representative of our data. So I would like you to try these two on your own, and then go ahead and click play, see if you got them right. First, our mean, adding them all up, 7 plus 12 plus 6 plus 88 plus 13 plus 18 is 144. And we have 1, 2, 3, 4, 5, 6 numbers. That gives us a nice 24. Then find the median. So we need to put these in order from least to greatest. 6, 7, 12, 13, 18, and 88. So our median, we have 1, 2, 2. We have two numbers in the middle, 12 and 13. So between 12 and 13 would be exactly 12.5. If you added them up and divided by 2, you would also get 12.5. Is there an outlier? Just by looking at these numbers, 6 to 18 is pretty close together. Then there's this huge number, 88. So yes, 88 is our outlier. Now find the mean without it. So instead of having 6 numbers, we only have 5. So we had 144 total before. So if we subtract 88, our total was 56 without the outlier. So 56 divided by 5 gives us 11.2. So it made our average or our mean go down considerably. And then our last question here. Does this data set have an outlier? Why or why not? It might help to put them in order. 23, 29, 34, 45, 55, and 63. So, in my opinion, I would say that this one probably does not have an outlier because 63 is about 10 from 55, which is about 10 from 45. So these are about the same distance apart, same 34. These ones here are closer together, but there isn't one point that is really far out there. Like if you had 0 or like 5, that might be considered an outlier, or like 100. But 63 to 55, there's only about 10 between these points, and they all have about 10 between them. So I'd say that this does not have an outlier.